Hi, I wasn't planning on doing another one of these anytime soon, but I had heard that Dr.John Kroon made an appearance on Rum and Coke on Steve's channel, so I had to check it out because I am a fan of Dr. Kroon. He's an astrophysicist. I wanted to share a segment that I saw that I found to be entertaining. It was an argument, or rather a disagreement between John Kroon and Steve McRae on a topic in physics. So again, let me repeat. This is Dr. John Kroon, astrophysicist, against Steve McRae, not an astrophysicist, on an issue in physics. Okay? Let's enjoy. Okay, let's take a closer look at both the participants in this argument. On the one side, we have Dr. John Kroon. He holds a PhD in astrophysics from George Mason University, and as you can see, he has a rather impressive work and academic experience, and I don't think he's 40 yet. So he was a research collaborator at George Mason University. He's a graduate researcher, he's an instructor, data scientist, just a brilliant, brilliant person in this particular field. He's brilliant and all, but today he'll be going against this powerhouse of logic and reason known as Steve McRae. Now let's take a look at Steve's work and academic experience. He went to nuclear power school, Knowles Atomic Power Labs. Since that time, he claims to have gone to college for 4 years, although he has no degree. He was able to leverage this 4-year non-college degree education into a job at Kohl's, where he helped people pick out shirts and shoes. After that, he went to Circuit City, and then he became the internet philosopher that we all know today. He was the co-host of the Non Sequitur Show, and he reminds us of that several times every stinking day. He is the co-host of Caffeine Corner, which is just an awful, awful show, 95% of the time, depending on if you have a guest like Dr. Kroon or not. Okay, without further ado, let's get right to the conversation.
I'm sorry, Sarah got a super chat. I missed a super chat. I did. Sorry. Sarah, I love you. Don't kill me. Sarah, super chat, $5. She says, John Kroon, do things like virtual particles and radioactive decay defy causality?
No.
No.
Oh, can you rephrase the answer in the form of a question, please?
That quick.
Okay, so the question was, hold on, let me just recap. Let's get a recap.
Yeah.
Do virtual particles and radioactivity
Violate causality?
I'm going to go with yes.
In what way? In what way would causality be relevant? Because Steve, in philosophy and epistemology.
Steve, can you mute real quick? I can't hear John.
The idea that a question contains within it an inherent assumption is entirely necessary for the person questions to understand if he or she wishes to adequately answer it. That's the philosophy of teaching.
I agree with you, but I'm going to give a little bit of principle of charity.
He misuses the phrase principle of charity so much.
I'm going to interpret the question this way, and this may be how she interpreted it, or she meant it. I hold that since it's already been proven that there's no theory in the Copenhagen interpretation that allows for a local hidden variable model that satisfies all conditions for Bell's inequality, therefore.
Now, I found that to be odd. He says he's going to interpret it this way, but he doesn't give us his interpretation of the question. He doesn't give us a rephrased question, but instead he jumps into an answer to this newly phrased question that's in his head, but he hasn't made it known to us.
Or you cannot have any causal relationship to anything that's going to happen in spontaneous fission, any kind of radioactive decay or virtual particles, because there's no information in the system prior to the event to have any causal relationship. So therefore there's a effect, but there's no cause to it because there's nothing relating to the effect. I would call that...
It's a non-determinate system.
It's an absolutely non-determinate system because there's absolutely no information to even be relevant.
These are false assertions. These are non sequiturs. They have nothing to do with virtual particles.
John, you got to put a trigger warning before that word. It's a sore subject. Oh my gosh, look at Chesh. Oh my God, she looks so adorable. Look at those bugged out eyes, all frightened in her I'm smart glasses. She's thinking, oh my God, this guy's about to wreck my boss live. This can't be good for business. And here's Manya. Here's Manya. She can't bring herself to look at the screen. She's so embarrassed. And this girl, I don't think she knows what's going on, nor does she care. She's just happy to have gotten an invite to the hangout.
In modern physics or radioactive decay. And so the way I can explain this is that if you were to look at a uranium atom, a uranium atom has 92 protons and 238, whatever 238 minus 92 is. And pick any two of those protons and any two neutrons. That's a helium-4 nucleus. Or alpha radiation.
Alpha particle, I think.
And you can calculate the time scale upon which this helium nucleus will tunnel out of the nucleus and be emitted as a radioactive decay. We call that alpha decay, and you get something like billions of years. And so there are physics governing dynamics of the universe at a fundamental level within the umbrella of quantum mechanics that allows this to happen. You don't need a first cause or a primary
disagree.
mover.
And then let me tell you why I disagree.
I do have a quick question.
Well, let me hang on one thing at a time. Everything you said obviously is actual physics, right? I agree with you 100%. But the question is, though, we can never determine when that event's going to happen, right? If we said, hey, look, I want to know when this HE2.
Oh, we can. Can.
You can never tell when a spontaneous diffusion.
Oh, yeah, you can. In aggregate, that's the whole point of
Can I add a comment quick?
If I were to.
This is amazing. This is amazing. Dr. Kroon is a legit astrophysicist, and Steve comes strutting in with his Circuit City swagger after having read a popular science article that oversimplifies a topic for laymen. Steve spits out like this casserole of scientific terms that's largely irrelevant to the question asked, and he thinks he's really saying something. He must have thought at the end of that monologue, Dr. Kroon would go, wow, Steve, I'm really impressed. Steve, nobody is impressed. Nobody is impressed.
Oh, we can.
You can never tell when a spontaneous diffusion.
Oh, yeah, you can. In aggregate, that's the whole point of
Can I add a comment quick?
If I were to say, look, hang on.
It's ensemble statistics.
Let's say I have a neutron in a non-bounded condition. Okay, and what's the lifespan? Like 3,000 seconds for something like that. So if we have whatever it is, so we have a non-bounded neutron. There is no particular way we can say this is going to decay at this particular time. It is impossible to determine that. Correct?
Sure.
Okay, so if it's impossible to determine that, the reason being is in the system itself, there's nothing to be had that we can ever have access to. No local hidden variable that we can say, hey, we're missing information, and if you knew about this information, we can make this determination. We can't make this determination.
I thought Chesh was trying to abort the stream on that one.
Because there is no information to be had to even know. It is completely unknown. That's the causal breakage that I think Sarah's talking about.
Say that about Las Vegas, and people still go there.
No, it's not but it's not stoichiometry. It's not like
probability. It's probability. That's what quantum mechanics is, Steve. You know quantum mechanics.
Well, I mean,
Okay. John has a dry sense of humor. They don't teach you quantum mechanics at nuke school. Sorry. John knows this. He's just having a little fun. Okay, I'm not going to interrupt anymore. We're going to play. I'm going to play 3 more minutes, and I'm just going to wrap up, and I'm just going to let this play out.
That's why I disagree. I don't think it's stoichiometric. Right, stoichiometric would be.
I'm pretty sure you know quantum.
Well, I just have the concept.
Okay, once more. I think Steve means stochastic. I don't think he means stoichiometric.
Sure, but I don't.
You're trying to argue that quantum mechanics is wrong. Is what you're doing. And
No.
Can I add a comment quick?
In the entire field of modern physics, it is the most well-tested and
I'm actually agreeing with the Copenhagen interpretation.
Entire universe. Yeah, but you're bringing up all these things that are not necessary. Hidden variables. You don't need them. No one's needing the person that asked the question never asked about hidden variables.
I think that's what she was.
Why are we talking about this?
Because that's what she's saying. Does it violate causality? Because there's no cause and effect.
Well, you can't put words in their mouth. Like
but I know who she is,
about
though.
causality. Causality
I can
is
give
not
principle
something that requires a human being to push something along at every stage of the way. We're talking about quantum probability.
This sounds like it needs to be its own show. That's what it sounds like.
Steve
Everyone has a
versus
question.
Dr. Kroon,
graphic and everything.
And by
Let's,
the way,
let's let
I want people to
Leo- let's
recognize
let
things. I want people to
I
recognize
haven't
this.
even got to
Yeah,
virtual
get
hang on,
pause and let
hang
Leo.
on.
I want to
Oh,
hear.
yeah, I know,
Hang on,
right?
hang on. I want people to recognize I love my friends when they do disagree. This is what we do.
Kick him out.
Now,
He disagrees
now,
with Steve.
now I gotta block you for the rest of my life, John.
You disagree with Steve. Off with your head.
Uh-oh.
John,
Somebody disagreed with Steve? Oh, no.
John Kroon,
What
birth
were
of
you
a
trying to say?
wait, birth of a McCrazy.
Worse is to disagree with physics. That's way worse than
I
disagree.
I'm not
wanted to
disagreeing with
comment
physics. I'm
and
the
then
one,
ask a
I'm the one
quick
that's
question.
agreeing with the
Who
physics.
needs physics?
Yeah, just talk over him. Go for it. Ask your question.
So, as I understand it, and I got a hold of, God, what's his name? It's Jake something. I can't remember his last name. He's an associate professor of astrophysics here at Iowa State University. And I asked him about radioactive decay, and it was described to me that it is considered a stochastic process where you can statistically analyze the system, but
Measure
you
aggregates.
can't
Yeah.
absolutely determine the system. So to give an example, you can look at a material that contains radioactive atoms. You can't look at any one of the singular atoms
Right.
and say, I know when it's going to decay.
That's an
However,
aggregate.
you can
Absolutely.
statistically analyze the whole system
But that's not what
and
I'm talking
determine
about.
over a given
I'm
period
not
of
talking about
time
the macro level.
how much of those atoms
look,
have
if I have
decayed.
100
Thank you, Leophilus.
Yes, Leo's right. If I have 100 atoms, I can look at that macro on the macro level and say, look, after a certain amount of years, let's say like carbon 14, which is 5,270 years. After that many years, half of that material is going to be gone. I can say that stochastically, yes. But an individual particle, you cannot stochastically say when that particle is going to decay. You have no way of knowing. It's
Exactly.
impossible. Because there's, like I said,
Exactly.
there is no hidden variables in that
that's
system.
true of most of quantum mechanics, isn't it,
No,
Steve?
no,
I mean,
no,
most of
no,
it
no,
is
because-
statistical
Hang on.
analysis.
No, in pilot wave theory, they do use global hidden variables.
Oh, come on.
Oh, Jesus
How many
Christ.
wrong things?
I mean, I look, Boolean mechanics
I
works. It's just more
quite like
complicated.
pilot wave theory, but that's just me.
It works. It works, right?
It works, yeah.
It's just more complicated. Well, John, one of these days,
Doesn't
he'll
the
go
many worlds interpretation work as well?
Sure.
So the thing about quantum mechanics is the only thing where experimentally we could verify it, but the interpretations about what fundamentally is happening is up to everyone. And there's not
Yeah.
even a majority on any of
That's true.
the dozen or so interpretations.
What do you prefer?
So it's
though?
just like,
Yeah, you're right. But what do you prefer?
I'm an old school. I like the Copenhagen.
me too.
You know what
I agree that I think it just
Many
it's-
worlds
it's-
just
it's-
kills
it's-
me.
yeah.
I can't.
You know what kills me, Steve? It's people who don't know what they're talking about acting like they do. Guess who I'm talking about? Okay, there's nothing wrong with challenging a professor. I think it's quite healthy, but there are ways to challenge someone with expertise in the topic, while also having the humility to simultaneously acknowledge that this person went to school for many more years than you did, and has worked in the field and has gathered a wealth of experience in the field, this field that you're talking about. So when you're conversing with someone who holds a PhD in the field with that type of expertise, you need to do more listening than talking. Just some free advice. All right. Everyone, have a wonderful day. Thanks for putting up with me for a few minutes. Okay, this is the end of my Steve rant, but I'm going to spend a couple of more minutes on my soapbox talking about something else. And that is the topic of speaking about things that is outside of your expertise, outside your knowledge. I have seen this in real life, on TV, in the online world, in different hangouts. When you're talking about science, specifically general relativity and quantum mechanics, these are very difficult concepts. This is very difficult physics. And you're going to have questions. I mean, I have questions. A lot of people are going to have questions. However, you have to have a certain amount of scientific literacy and physics background and mathematical foundation in order to absorb the information that you seek. Otherwise, it just becomes an exercise in futility. In fact, you would need that prerequisite knowledge in order to even produce questions that are not malformed without incorrect inherent assumptions like Dr. Kroon was talking about. I understand why people are interested in the various interpretations of quantum mechanics. It's sexy, it's intriguing. It's sci-fi books and movies are based on them. I mean, it helps scratch that curiosity itch that's part of human nature. You know, we want to know like where we came from, how how did human beings come to be? How did the universe come to be? So this is a topic that kind of gets us a little bit closer to that. So there's that attraction toward these types of topics, and it can be good at times. It can stimulate our creative thinking and imaginative thinking, but far more often than not, it just confuses you if you are ill-equipped. So that's a lot of words that I said to essentially mean don't jump into quantum mechanics with a high school diploma alone. You have to respect this. I mean, there are many baby steps, thousands of hours you have to invest, and thousands of problems to methodically work through, and concepts to really soak in and marinate. You can't just cram for it like it's some algebra test. You can't get by on some popular science article. There's no shortcut to this. There are several difficult concepts, and you're going to lose some essential meaning by delving into it in such a careless, reckless way. And if you find yourself in the presence of a PhD physicist or biologist or chemist, pick that person's brain. Humble yourself. Don't try to impress that person. Try to learn from that person. Anyway, that's my little rant on all that. Also, interpretations of quantum mechanics is one of the most difficult topics, and a little boring for me as well. And the reason for that, and I usually don't find myself bored in these types of topics, but the reason this bores me is because we don't have any evidence to support any of these interpretations, and I don't think we're going to get it anytime soon. And the reason I think that is because the farther back in time that we go, the data becomes more scarce. And none of the interpretations are supported by the evidence, as in evidence that bolsters one interpretation over another. There's a lot of speculation. It's more philosophy than science, which might be why Steve thinks he can mix it up with Dr. Kroon, which is why he tried to steer the question more into the quantum mechanics interpretations. He claims it was to give principle of charity to the questioner, but I claim it was so that he can kind of go into his rehearsed spiel. But anyway, it's just not interesting conversation for me, especially when it's discussed by a bunch of people who don't know what they're talking about. But I do like Dr. Kroon. I think he's awesome, and if he comes back on Steve McRae show or whatever show, I'll be sure to check him out. All right, that's it. Y'all have a great day.